Alright everyone, so in this example we have a mass hung from a pulley attached to another mass that's sitting on an incline. Two boxes are connected by a light string that passes over a light frictionless pulley. One box rests on a frictionless ramp that has a 30-degree angle to the horizontal, and it's released from rest. The first thing we want to do is draw free body diagrams, and then from there we want to figure out what's the acceleration and which way is the 50 kilogram mass going to move. So we'll call the 50 kilogram mass, mass 1, and the 30 kilogram mass, mass 2. For mass 1, we have the force of gravity, and the normal force, and the tension in the string. For mass number 2, we have the tension in the string, and the force due to gravity, or the weight of the mass. Remember that we can break the force of gravity down into two components, one which opposes the normal force, and one which points down the incline. So here we can choose the positive x direction to be in the direction of the incline, as if the block were moving up the incline. By doing this, we know the force of gravity that's pulling down on it from it being on the incline. But we can also determine whether or not the block is moving up the incline or down. If we find that there's a positive acceleration in the positive x direction, then the block will move up the incline. If we get a negative acceleration, then the block will move down the incline. So paying attention to signs is important. We can then envision this as two masses attached by a string in the middle, as we did with the problem before. Mass number 2 has the force of gravity or the weight and the tension. And in the same dimension, mass number 1 has the tension and the x component of the force of gravity, component that points down the incline. And so we can use Newton's second law to write equations for each one of the masses. So for mass number 1, we have the tension minus the force due to gravity is equal to mass times acceleration. For mass number 2, we have the force due to gravity minus the tension is equal to the mass times the acceleration. And again, because we know the tensions are equal, we can combine the two equations in that way. So now we can rewrite our equations in terms of tension and use that to solve for the acceleration. Now remember that the force due to gravity on the second mass was just the block's weight, so the mass times g. If we distribute the minus sign, and remember that the x component is the component that points down the incline, so we use the sine of the angle. So we can now solve this equation in terms of a. And we find that the acceleration is given by m2g minus m1g times the sine of theta divided by m1 plus m2. So the weight of the second block minus the component of the weight from the first block divided by the sum of their masses. And when you plug all of this in, you find that the acceleration .6125 meters per second squared. And so because the acceleration is positive, that means that it's moving in the positive direction, which means that the block's going to move up the incline. One final note I want to make here is that we could have plugged the numbers in much earlier in the problem and just solved for A. and you would have gotten exactly the same answer. But by solving it this way, we've established a formula for now. It doesn't matter what the angle is of the incline. Any setup in this manner, and we can use this formula to find the acceleration.